My name is John Greer, and today I'm going to be covering a statistical concept called acceptance sampling. In this presentation, I'll define this concept and talk about the statistical foundation, and then I'll go into its uses as well as some of its strengths and weaknesses. So what is acceptance sampling? It has to do with the quality of a sample and also the balance of producer and consumer when it comes to producing and distributing samples. The group of items that will be analyzed is called the lot. Now, a good example of this would be if I receive a package of 1,000 phone charger cables, which is our lot, and I'll decide whether or not to accept it or reject it. Much like any sample, I would find the defective rate, and then if I find that the defective rate is relatively high compared to my risk point, I'll reject it, but if it's relatively low, I'll accept it. That's more of a conceptual basis, but here we have a statistical foundation. In a study done by G.B. Weatherall and W.K. Chu, they outlined the statistical foundation using the operating characteristic curve. The equation takes a batch with size n and operating quality of theta and tells us the probability that the consumer will accept it based on their risk point. This is a graph of the operating characteristic curve that shows the producer and consumer's risk points, and based on the data in the curve, whether they will accept or reject the lot. So how does this apply to the engineering world? Misrepresentative samples are very common, which will throw off our entire data analysis because it all stems from the sample being used. Acceptance sampling allows us to fix this problem by not only accepting lots satisfying our risk point, but also it means we're working with smaller numbers compared to large numbers, and overall it helps us maintain quality, reputation, and economic stability. In the study done by Weatherall and Chu, they give multiple ways acceptance sampling has been used in the different techniques involved. The study mainly focused on the economic applications of acceptance sampling and the relationship between producer and consumer. From a producer standpoint, we use acceptance sampling so we can provide consumers with the most representative sample, which will also cost more than a less representative sample. There are multiple approaches outlined in the study, such as the Minimax principle, Bayesian approach, semi-economic approach, and incentive approach. These are all based on the producer-consumer relationship where the engineer is looking for a lot and the producer is looking to sell a lot. Finally, we'll look at some of the strengths and weaknesses. The main weakness is that there's subjectivity in the process. While statistic narrows down our choices, as consumers, we still have to make the choice based on cost, risk point, p-value, etc. So if you're unexperienced, you may misstep somewhere. Another weakness is the fact that money is involved. When money is involved, there's vested interest and data can be skewed. The biggest strength is that we can take a sample and apply it to a larger scale, and this is going to save us time, money, and headaches. It gained popularity in World War II, where we're just pumping out war materials, and after realizing that the technique was useful and time-saving, it spread, and it's now crucial to the industrial world. Another strength is that it guides us as engineers in the right direction when choosing our sample, so we're not just picking with little information or based on what looks right subjectively. So to wrap up, acceptance sampling is a highly useful technique from statistics that engineers can utilize in their respective fields.